So welcome to my next session on graph theory. Here we talk about isomorphism in graphs. So we learn what are isomorphisms and how to identify if two graphs are isomorphic. Two graphs G and G' are isomorphic if there exists a one-to-one correspondence between their vertices and edges such that adjacency of vertices is preserved. So two graphs are isomorphic if they have the same number of vertices, same number of edges, and equal number of vertices with a given degree. Now there is no hard and fast rule for proving isomorphism. You have to examine each graph individually and see how it is. Two directed graphs are said to be isomorphic if there exists a one-to-one correspondence between their vertices and edges so that adjacency of vertices along with their direction is preserved. So in addition to adjacency, the direction also has to be preserved. Are the following graphs isomorphic? Justify. So the first graph, this is the first graph and this is the second graph. There are 4 vertices each, 4 edges each, and each vertex has degree 2. So there exists a one-to-one correspondence between the vertices such that adjacency is preserved. Hence the two graphs are isomorphic. Question 2. Are these two graphs isomorphic? Now G1 and G2 have 10 vertices and 15 edges each. You can see that there are 10 vertices and 15 edges in each, and each vertex is of degree 3. So each vertex is of degree 3. You can check for yourself. So there exists a one-to-one correspondence between vertices so that adjacency is preserved. Hence G1 is isomorphic to G2. Question 3. Are these two graphs isomorphic? Now degree of V1 is 1, degree of V2 is 1, degree of V3 is 3, degree of V4 is 2, degree of V5 is 2, degree of V6 is 1, degree of U1 is 1, degree of U2 is 2, degree of U3 is 3, degree of U4 is 2, degree of U5 is 1, degree of U6 is 1. Now degrees of the vertices are the same. You can check that. There are 2 vertices, 3 vertices of degree 1, 2 vertices of degree 2 and 1 vertex of degree 3. A degree 3 vertex in G1 is joined to 2 vertices of degree 1 and a degree 3 vertex in G2 is joined to 1 vertex of degree 1. This degree 3 vertex in G1 is joined to 2 vertices of degree 1, whereas this degree 3 vertex in G2 is joined to only 1 vertex of degree 1. So the adjacency is not preserved, so the graphs are not isomorphic. Question 4. Are these graphs isomorphic? Now, number of vertices in G1 and G2 is 8 and number of edges is 14. You can check that. 8 vertices and 8, 9, 10, 11, 12, 13, 14. 14 edges. Now degree of V1 is 3, degree of V2 is 4, degree of V3 is 3, degree of V4 is 4, degree of V5 is 4, degree of V6 is 3, degree of V7 is 3, degree of V8 is 3. Also degree of U1 is 3, degree of U2 is 4. U1 is 3, U2 is 4, U3 is 4, U4 is 3, U5 degree is 4, U6 degree is 4, U5 and U6 have degree 4, U7 has degree 3, U8 has degree 3. So G1 has 3 vertices of degree 4 which are V2, V4, V5 and 3 vertices, and G2 has 4 vertices of degree 4. So the two graphs are not isomorphic. Next question. Are the following diagrams isomorphic? The number of vertices in G1 and G2 is 4 and number of directed edges in G1 and G2 is 4. Each vertex in G1 and G2 has in degree 1 and out degree 1. So you can check that in degree is 1, out degree is 1 for each vertex. So adjacency of vertices along with direction is preserved, so G1 is isomorphic to G2. Next question, are these two graphs isomorphic? Both G1 and G2 have 5 vertices and 7 edges. You can see that. You can count for yourself. Now in G1, A has in degree 2 out degree 1. In degree 2 out degree 1, B has in degree 1 out degree 1. C has in degree 2 out degree 2. In degree 2 and out degree 2, D has out degree 3 and in degree 0. E has in degree 2 and out degree 0. In degree 2 out degree 0. Again, if you look at P has in degree 1 in degree 2 out degree 0. Q has in degree 2 out degree 2. In degree 2 and out degree 2. R has in degree 1 out degree 1. S has in degree 1 out degree 2. In degree 1 out degree 2. And T has in degree 1 and out degree 2. So in degree of A is 2 and out degree is 1. But no such vertex exists in G2 with in degree 2 and out degree 1. So the two graphs are not isomorphic. So you can see that each problem is different and you need to check each graph, each degree of the vertex, each in degree, out degree separately to check if the graphs are isomorphic. I hope that this has helped you to learn something about isomorphism. Do feel free to contact me for further help. Thank you.